So, hello everyone, my name is Ishan Kumar, and today we are going to discuss this problem, which is multiply by 2 and divide by 6. It is totally based on math. It is currently 900 rated on Codeforces. So, let's read the problem and understand what it's trying to say. We are given an integer. In one move, you can either multiply n by 2 or divide n by 6 if it is divisible by 6 without the remainder. Your task is to find the minimum number of moves needed to obtain 1 from n or determine if it's possible to do that. You have to answer t independent test cases. Okay. So for the time limit for this problem, we are given 1 second, and as an input will be given two integers. First will be t, the number of test cases, and the second will be integer n under every test case. Integer n we have to check if that number we can convert it or drop it down to 1 or not. Is it possible to drop it down to 1 or not? And as an output we have to give the minimum number of moves required to obtain 1 from that number, and if it's possible or not. If it's not possible, we are going to return -1. So let's see. So we will be given a number n, an integer n as input. So we are given two operations. We can perform two operations, but in one move we can perform only one operation. So the first operation will be we can multiply the number by 2, or we can divide the number by 6. We can divide the number by 6 only if the number is totally divisible by 6. It means it does not gives any remainder, leaves any remainder. So in each move we are allowed to perform any one of these two. So what we are going to do is that uh, we'll first check if the number is divisible by 6 or not, because we have to drop the number down all the way to 1. Our last goal is to drop the number to 1 and obtain 1, and also check if it is possible to obtain 1 or not. So what we'll do is, first of all, we'll check if the number is divisible by 6 or not. First we'll check divisible by 6. If it is divisible by 6, we'll divide it by 6, because dividing it by 6 it will lower it very much, because our final goal is to obtain 1. And if not, what we'll do is that we'll check if n into 2 is, because there are only two operations we can perform. We can either divide by 6 or multiply by 2. So we'll check if multiplying the number by 2 is divisible by 6 or not. So why I'm doing is, I'll tell divise into 2 is divisible by 6 or not. So why I'm doing this is because, let's say we have a number and we are given these two operations. We can perform these two operations many number of times. We do not have any endpoint for this, but here I am setting an endpoint for this number by checking if the number that first of all we'll check if the number is divisible by 2 or not, 6 or not. And if it's not divisible by 6, we'll first check if the number multiplied by 2 is divisible by 6 or not. By 6, what that will do is that, let's say if the number is divisible by 6, then we'll multiply the number by 2. If it is not divisible by 6, we'll just end the process there and say that it is not possible, because we have only two operations, and if the next number is not divisible by 6 after multiplying it by 2, then no there is no operations left to do, and get it will be impossible to get 1 out of that number. So this is the boundary that I am setting. Otherwise, we'll just go on all day multiplying it by 2 and dividing it by 6. It will never end. But by setting this, I'm setting a boundary by checking if the next number is divisible by 6 or not, and if it is divisible, then only I'm going to multiply it by 2. Otherwise, I'll say that it is impossible to get 1 out of it because we have only two operations and we will not be able to perform the second operation in the next move. So it's waste of time moving on to the next move. So this is going to be the logic for the push problem. Let's look at the code and analyze the test cases. So here I have taken T, which is the test cases, and right here I have taken N, which is the integer given as input, and so in the question it is mentioned that we have to give the output the number of steps taken to drop the number to 1. It means we do not have to say that it is possible or not. If it is possible, we have to tell in how many steps the number is going to become 1. And if it's not possible, we're going to just give -1. So the minimum number of moves needed to obtain 1. That's the output that we have to provide. If it is possible to drop it down to 1. So I've taken count, initialized count, and I've also initialized a boolean true. Let's say I've started an iteration until n becomes 1. So first of all, I'm going to check if the number is divisible by 6 or not. If it is divisible by 6, I'll divide it by 6 and increment count. If it is not divisible by 6, I'll get into else, and in else I'll check if the number multiplied by 2 is divisible by 6 or not. This is our endpoint. This is the boundary that we are setting for the problem, and if it comes true, then we'll multiply the number by 2 and increment the value of count. If it is not true, we'll just give out the possible will be false, and we'll break through the loop and we'll just print out -1 because the next step will have no operations left if it is not divisible by 6. So it will be impossible to get 1 out of it. So that's all in this problem. Let's take some test cases and check. Let's take these 7 test cases and check if our logic is correct or not. So this is problem 1374B. So let's compare the answers. First one is 0, second one is -1, which means it is not possible to obtain 1. The third case, which is 3, we have given 2, and 2 steps will attain 6. For 12, it is -1, it is not possible. For 1, 2, 3, 4, 5, it is not possible again. For this number, it is possible in 12 moves. Right here, it has shown all the 12 moves. And for the last number, it is possible in 36 moves, and that's what we are getting. We've given 1 second of time to operate, and I've used only one iteration, so it won't be a issue of time complexity, and my answer has been submitted successfully. So this problem was totally based on maths and observation, how much you observe in the problem. Yeah, this question has been accepted, this code. That's all for this problem. I hope you understand it well. Thank you.